3I Atlas is doing 3I Atlas things again. Since the interstellar chunk was discovered in the summer, it has turned practically everything we thought we knew about comets upside down. Recently, the object passed its closest point to the sun and once again behaved completely different than scientists had expected. Just like Oumuamua before it, 3I Atlas exhibited a mysterious acceleration that cannot be explained solely by the influence of gravity. Added to this was an unusually rapid and strong increase in brightness, and spectacular evidence that our guest is covered with structures that absolutely no one had expected. But what does all this mean in concrete terms? Are the signs now mounting that the interstellar visitor is in fact something completely different from a natural space rock? Or can the supposed anomalies be explained in other ways? Be sure to stay tuned until the end and find out with us. On October 29th, 3I Atlas reached its perihelion, the point in its orbit closest to the sun, giving Avi Loeb yet another opportunity to make a, well, astonishing statement. The Harvard professor is currently best known for his unorthodox views on the interstellar visitor. While the majority of experts are now certain that 3I Atlas is a purely natural comet, Loeb continues to keep some alien backdoors open. Specifically, this means that he repeatedly refers to the object's unexpected and puzzling characteristics, and always raises the question of whether something artificial might have entered the solar system after all. Apart from spaceship theories, however, the perihelion is always a crucial moment for a comet, because that is when it passes through the hottest and therefore most dangerous part of its journey. As a result of the close proximity to the sun and the associated solar radiation, the chunks lose more ice, which sublimates directly into gas and carries more rock material with it. Some comets do not survive this critical phase and break apart, but 3I Atlas approached the sun unscathed at a distance of 203 million kilometers. However, this is not the decisive factor for Loeb. The even more exciting question is what our mysterious guest was doing when it temporarily disappeared from our earthly field of vision. Loeb writes about this on the Medium platform. Quote, "For a spaceship, perihelion is the optimal time for acceleration or deceleration by means of an engine impulse, thanks to the gravitational assistance provided by the sun. This also applies to a mothership that sends out mini probes that move toward the planets." Okay, so far, so crazy. And yet, we must not forget that exactly this kind of behavior has already been observed in another interstellar visitor. Of course, Oumuamua did not release any research probes in 2017 to spy on our planetary system. Well, at least not that we know of. What the interstellar firstborn did deliver, however, was a tiny but mysterious acceleration near the sun that cannot be explained solely by the influence of gravity. Of course, Avi Loeb spoke up even then, noting that Oumuamua would exhibit exactly the behavior one would expect from an artificially created solar sail. And now history seems to be repeating itself. Observations with high-resolution telescopes, such as the ALMA radio telescope, have shown that 3I Atlas deviated significantly from its predicted trajectory during perihelion. The bottom line is that the deviation was about 4 arc-seconds, from which astronomers delivered a non-gravitational acceleration of about 0.02 millimeters per second squared. Translated into plain English, this means that the chunk could have changed its speed by about 86 meters per second within 50 days. And that's an enormous number when you consider that comets normally deviate only minimally from their gravitational trajectory. How scientists explain the acceleration. The crucial question now is how the research community will respond to this unexpected behavior. Do we now have 2 cases of exotic objects from alien worlds that push our models to their limits? Well, not necessarily, because it's actually possible to explain the acceleration without resorting to extraterrestrial propulsion technology. This is where the aforementioned outgassing of volatile substances comes into play once again. As 3I Atlas approached the sun, gases such as CO2 and CO sublimated from its surface and escaped at high speed. And that's precisely the key point. Ultimately, the released gases actually act like tiny but purely natural engines that influence the flight behavior of the chunk. This mechanism explains both the direction of acceleration, which points radially away from the sun, and the measured value of about 0.02 millimeters per second squared. Models show that even a normal proportion of active surface area, or in other words, the areas where gases actually escape, and a moderate alignment of the gas jets are sufficient to explain the observed acceleration. So no alien propulsion systems are needed to understand the behavior of 3I Atlas. And the same applies to Oumuamua, incidentally. Experts now explain its unexpected thrust by the radiation-induced decay of water ice, which formed a tail of invisible hydrogen gas. However, 3I Atlas would not be 3I Atlas if this had been the only surprise during its perihelion. Basically, the outgassing intensified by solar radiation not only triggers a natural rocket effect, it also increases the brightness of a comet. This is simply because the escaping gas ejects dust that reflects light. But 3I Atlas became brighter much faster than expected. However, as we still have no idea what is responsible for this, researchers Qichang Zhang and Carl Badams summarize the situation in their paper as follows. Quote, "The reason for the rapid increase in brightness of 3I Atlas, which far exceeds the brightening rate of most comets in the Oort cloud at comparable distances, remains unclear. However, there are at least several possibilities on paper for approaching this mystery. On the one hand, there is the rather unconventional hypothesis, which, in the best Avilobe style, links the rapid increase in brightness to a spacecraft that has released a series of research probes. Not quite as far-fetched, on the other hand, is the approach that the development is related to the rapid speed at which 3I Atlas is sweeping through the solar system. Specifically, its orbital velocity during perihelion was approximately 250,000 kilometers per hour, making it one of the fastest objects ever observed in our home system. However, the solution to the mystery may also lie in the internal composition of the comet. The surprisingly high ratio of CO2 to H2O, which was recorded in the course of spectroscopic investigations, shows that it's very different from what we know from our local chunks. In addition, 3I Atlas appears to release nickel but no iron, which is highly unusual, as comets usually emit both metals together. For experts, however, this mystery also holds enormous potential for insight. Such chemical signatures can tell us a lot about the structure of the original system in which our guest was born billions of years ago. Is 3I Atlas covered with ice volcanoes? When 3I Atlas passed its closest point to the Sun, it was also targeted by 3 space probes facing the Sun, and the corresponding images not only highlighted the rapid brightening of the chunk, but also seemed to show that the object is significantly bluer than the Sun. In earlier observations, however, the surrounding comet dust still shimmered in a rich red, while later it took on a green color. But what is the reason for this? Is our visitor like a cosmic chameleon that regularly changes color? Researchers attribute the change to green to newly released gases, and the change to blue, not at all. However, this is not because those responsible are refusing to comment, but because 3I Atlas is not believed to have changed color at all. Qichang Zhang, who participated in the study, writes, "We have no evidence that the gas coma is changing colors. Our results simply show that the gas coma is probably still present and contributes significantly to the overall brightness." What contributes significantly to the overall amazement is another exciting observation that no one had anticipated in advance. Data from several observatories in Spain suggests the spectacular conclusion that ice volcanoes could erupt on 3I Atlas. When the chunk became brighter during perihelion and developed stronger jets, it revealed structures that are indeed reminiscent of cryovolcanism. Using the Joan Oro telescope, experts have obtained the most detailed images of these gas and dust jets to date, and they interpret them to mean that the comet's interior contains original, reactive materials that can trigger actual eruptions when heated. What is particularly astonishing is the fact that the composition is similar to that of trans-Neptunian objects. As the name suggests, these are bodies that travel beyond the orbit of the outermost planet Neptune, but 3I Atlas is known not to originate from there. To test their assumptions about the comet's composition, the researchers conducted a spectroscopic comparison, an analysis of how matter absorbs, reflects, or scatters light. To do this, they used primitive, completely unaltered rock meteorites, known as carbonaceous chondrites, which NASA had once recovered in Antarctica. In one of these samples, the scientists even found fragments that they believe originally belonged to a trans-Neptunian object. And the comparison showed that the spectral properties of 3I Atlas are remarkably similar to these relics from the early days of the solar system. This in turn suggests that the interstellar comet is rich in natural metals and consists of very primitive material. Despite all the similarities, however, there is no question that the roots of this chunk must lie in a completely different star system. Its highly hyperbolic orbit and breathtaking speed leave no doubt that 3I Atlas is traveling far too fast to ever have been captured by the gravity of our host star. But the gravity of your click can now capture a new subscription. Simply press the thumbs up button and subscribe to never miss a new video from us again. See you soon.